Hi guys, so here we're going to look at electron arrangement. So you'll definitely need your periodic table for this. I'm going to cover what electron arrangement is, or electron configuration is, how it looks for ions, and then excited versus ground state. So your electron configurations for your New York State reference tables are actually located in the bottom left-hand corner. So if you notice there's numbers with dashes, the numbers represent how many electrons are in each different sublevels. So for example, with carbon here, there's 2 electrons in the first sublevel. So if I have, let's see, the protons and neutrons in the nucleus, and then I have electrons around it, there's 2 electrons in that first level, and then 1, 2, 3, 4 electrons in the next level. So if you look on the bottom left-hand side of all of these elements, they'll show you what those electrons are. If you notice down here, pretty much starting around here, there's a dash. Take a look down at the key. They tell you or explain to you that there's actually more electrons, so like 2-8 before it. So when we have ions, we actually, ions will gain or lose electrons, or excuse me, atoms will gain or lose electrons in order to become atoms. So for example, if we have beryllium here, it's 2-2. So it's going to actually lose 2 electrons to have the noble gas an electron configuration of a noble gas. So if you go back to 2, it's helium. It's one of the noble gases. If you take a look at strontium, it's 2-8-18-8-2. Strontium will lose 2 electrons, and then its noble gas configuration will mimic that of krypton. So it actually ends up having a +2 charge because of that, and that's why, again, you have that +2 over there. If we take a look at sulfur, sulfur is 2-8-6. So it will gain 2 electrons in its outer energy level to be 2-8-8, and it has the electron configuration of argon. So metals will lose electrons from their valence shell, and their last energy level will therefore then have 8 electrons, unless it's going to be mimicking helium, which only has 2 electrons in its outer energy level. So for example, potassium, we have 2-8-8-1, and what will end up happening is that its ion will look like 2-8-8 because that last electron will be lost or given away. For strontium, we have 2-8-18-8-2, and again, those last 2 electrons will be given away, and it will mimic the noble gas configuration, electron configuration of the noble gas before it. Now metals will gain electrons, so we have chlorine here. That's 2-8-7. That last electron level will gain the last energy level will gain an electron, for example, from potassium or from strontium, and therefore end up looking like 2-8-8. It hasn't become that next noble gas, but it has the same electron configuration as that next noble gas, and it has 8 electrons in its outer shell. Since it has gained an electron, it's at -1 charge. With oxygen, it's 2-6. Again, it'll gain 2 electrons in its outer energy level to be 2-8, to again mimic the electron configuration of a noble gas, and since it gained 2 electrons, it's now a -2 charge. In excited versus ground state, remember or think back to the flame test. When we added energy, these electrons actually ended up moving up energy levels. So you might see that we have potassium here, 2-8-8-1, and that's what this electron configuration is. Again, 2 in the first shell, 8 in the next, 8 in the third, and then 1 in the fourth shell. Well, what might end up happening is that we end up having 2 electrons, or even 1 electron, move up an energy level. So now it could look like 2-8-7-2. It still has the same number of electrons as the regular ground state configuration of potassium, but the electrons are in a different sublevel or energy level. So this is the ground state, and this is the excited state. One thing you definitely want to make sure you remember, key into, is that the ground state and excited state will have the same number of electrons. Again, make sure you write this down so that way you have it. With ions, on the other hand, going back, they're actually going to gain or lose electrons in order to become that ion. so they won't have the same number of total electrons. Alright, so just to summarize electron configuration, lower left-hand corner, it tells you how many electrons are in each level. If there is an ion, that atom will gain or lose electrons to become an ion. And if it's in the excited state versus the ground state, the excited state just one of the electrons will move up a level. And there's a ton of different possibilities for the excited states as well. So you just want to make sure that you have the same number of electrons. They will just be in a different order for the ground state versus excited state. Have a good day, guys.